before 2.0, to get started off with REST APIs, we need a basic understanding of Python. So there is going to be a, before we start with this task, with this section, there'll be a kind of crash course on Python, I would say. But Python, you can just, there are umpteen number of resources, right? You can pick up any of the, like David Bumble himself, right? The network, Python for network automation. So you can pick up and then start going through. Over this weekend itself, you can start so that you will start, some things at least will start making sense. Because there are lots and lots of Python stuff like REST APIs, Click, NC client, NetMiko client, NetConf, RESTConf, Jinja, Scraply, NetMiko, and so PyATS, so many are there. Zamet Python SDK, it's like everyone can create their own software development kits. So many things are there with Python. Python is like kind of undercurrent. It runs throughout. So I would suggest start brushing up on your Python. If you don't know anything, just take up David Bumble's course, Python for network automation, and how many labs? I don't know what do you mean by how many labs, but yeah, these are the high-level topics which are there in the labs. Would you require Linux? We have, Cisco gives us a sandbox. So kind of, not sandbox, it's a box with pretty much everything set up that we have made it available through our link as well. So you can either take it from us or directly from Cisco, it doesn't matter. So you will get a box with Linux. It's a Ubuntu box with pretty much everything preset on that. It is not exactly CCIE Devnet syllabus. It is based on that. David Bombal, B-O-M-B-A-L. Yeah. Okay, so that's about lab highlights. REST APIs, then Python, some stuff, then some more Python libraries, then GitLab, CI/CD pipelines, then Epic APIs, network test automation, secrets management, and some more APIs, SDKs, some concepts like model-driven telemetry, and then Docker. Well, there are some tasks, right? For example, NetMiko, NetConf, RESTConf, these have something to do with network devices. So there you would be needing some device, at least one or two basic devices, right, which support these things. So there you would be needing EVNG. The box which Cisco gives, it's only a Ubuntu box, right? So in addition to that, you can supplement it with EVNG Community Edition, which you get, and there are also some Google Drive locations from where you can get pretty much any image for free of cost and set up at least one or two basic images. Check on the WhatsApp groups, please, for all the, or you want to take it forward. Okay. Setting up and getting started. What would you need? We already discussed this. We need a DevNet kind of VM, which means with all the prerequisite software setup, Python, Ansible, Docker, Terraform, etc., etc. Now this is available as a OVA file, as I already said. So you need either a VMware workstation player or either a VMware player or a workstation. If it's a free edition, is also well and good. Right? And then we need any code editor. In fact, these code editors are pretty much present inside the box itself, the box that you're going to download. And these are the download links. I'll be sharing the document, but I mean, I don't want to share it now. So otherwise you'll start downloading and then your focus will go there. Right. So the VM image we have provided through our drive. Either you can take this or I can give you directly the Cisco image also. There's not much difference. Workstation player and Visual Studio Code. Right. Now, when you download it and set it up, you're going to get, basically you're going to get, this is my VMware workstation. So I can, what just happened? Okay, when you download it, it's available as a zip file. You just unzip it, open, there'll be a OVF file, open it, and then that gets imported and is available as this. Then depending on your underlying system's resources, you can just go with the defaults or you can modify. Right? If you just have 8 GB RAM, maybe you can make this as 6 or 4. But then you'll have to have only this running. I mean, when you want to practice this, you'll have to stop your other work for better performance. You start it up. What about Mac? Mac also will have some, this VMware workstation is available on Mac also, right? Yes, I'll be sharing this guide. So that's why I said I don't want to give the links now. Yes, you can get this VM as well as EVNG Community Edition is. I have that link somewhere. WSL you can use, but yeah, you can use. If you have WSL, you can very much use. But if you have other code editors and everything, if you want, and you want to keep your work entirely separate, you can go with this option. The password for this is just the same, DevNet Student. And you have your Postman for APIs, you have your Visual Studio Code, you also have PyCharm, then Atom. You will not be needing so many IDEs. These are all IDEs, integrated development environments. Someone who doesn't know, who is new to coding, IDEs are like, I mean, we have Notepad where we type some text, right? Text editor. Notepad is the basic text editor. Then a little more advanced, we have Notepad++. And earlier we had something called as TextPad. Now we have Notepad++, which gives little more decent features. Then we have a little more advanced Visual Studio Code. Not little more, it's very much advanced. So we have text editors, then code editors. Then the next level is IDEs, integrated development environments, which means if you are doing some coding or doing some automation, doing some scripting, you don't have to leave your IDE to test your code, to run it and see. You can do it everything from within the IDE itself. That's why we call it as integrated development environment. Right? So what you're looking at are all these: Atom, PyCharm, Visual Studio Code. These are all these things. Then and you have pretty much everything set up. Your Python set up. Ansible, I just need to check if it's there. It should be there. Okay, it will be there in there's something called as a virtual environment. Docker is there. And pretty much everything will be there in this. Okay, let's jump in. No, it's not being recorded. VS Code is simple and recommended. You can get VS Code. Okay, gentlemen. So I'm not sure how many are there. Okay, good, 200. So as I said again, right, there are 200 of us here. You might be from varied backgrounds, varied these things. So it's really a challenge for anyone, not only for me, for anyone to satisfy all of you. So I'll try my best by starting at the basics, as most of you have been asking me. Obviously, we understand that we are starting with something new, so we'll be starting with absolute basics. But if you are already familiar, then yeah, bear with me. Okay. So nowadays, if you see, the entire world is changing, becoming automation centric. Everywhere, automation, right? Automation is becoming the key thing. So keeping that in view, the kind of tools that are being created are also changing. And first, you had on-premise data centers where pretty much everything used to happen in the on-premise. Then the demands of the business grew. They wanted elasticity. Like suddenly you have 100 new customer or 100 new clients, each client having 1,000 users, let's say. So that's about 1 lakh users. Trying to access your application from tomorrow or the day after. So suddenly you need to ramp up your resources, which is not very easy for you to do in your on-premise data center, right? Overnight, you cannot set up a large number of servers. So that's where the cloud platforms come in, right? Typically, to explain the cloud in the best manner, right? I would take the example of this. Yeah, at least in India, we have this. We have, let's say, functions. A small function I can manage with whatever utensils that I have at my home. A little bigger function, I'll try to check with my neighbors. Do we have bigger utensils which I can use for cooking? Let's say I have a huge function where I'm expecting large number of guests. Right? Of course, nowadays you give everything for catering, but at least in the few years back, we used to borrow things from something called as a tent house, right? The guys who keep big vessels on lease, right? You go, lease them out, finish your function, and then give it back. So cloud is something like that, right? These tent houses, AWS, Microsoft and Google, to name a few, because they are more popular. They have set up huge amount of servers because they can afford to. They set up huge amount of servers. Now they don't know what to do with all that computing power. They started saying, yeah, take it on rent. So if I need, suddenly I need a computing power, I can borrow from these guys. So that's cloud in short for you, right? Now, to meet the business of the demand, right? I know I should be able to quickly say, okay, I decided to go with one cloud provider, say AWS. Now I ask AWS, tomorrow I'll be needing 10 so-and-so machines. Yeah, so they'll say, yes, you can go to the dashboard and create the machines. But going to dashboard and picking each machine type and creating it by selecting all those options. If you have created AWS EC2 instance, right? There are so many screens you need to go through, select so many options and then click next. Same thing is with Azure, right? Either you can go with all the defaults by giving most basic ones, or you'll have to run through screens if you want to really customize. So it's going to be tedious. And imagine you're not going to do this once or twice, you are going to do this so many times, again and again and again.
And cloud resources are costly. Obviously, you don't own them. If you own the vessels, it's costly. It's okay. It's reasonable. But if you're borrowing from some of them, obviously it's going to be costly. But the advantage that you get there is when you don't need these resources, you can release them. You can stop paying for rent for that and you can release them. Right? So for that, even if it's a little costly, you'll go with that. But having said that, the resources that you cannot keep them running forever. Right? You want to shut them down. You shut them down again, or you destroy them, and spinning them up again is highly impractical using your manual methods. So you want to have automation. So one such tool which can automate provisioning resources on the cloud, primarily on the cloud, is Terraform. Right? This is a tool which will help you to provision infrastructure on the cloud. I'm stressing on the cloud. It can very well be used for your on-premise resources as well, provided you have something called as providers. You do not have permission to record, unfortunately. I mean, either you record it or I record it. It's one and the same, right? We don't want to. Okay. Prerequisites for the class. I didn't have any prerequisites except that you come with lots of attention and pay attention to the things that are being said. Certainly, you will take back something. Yeah, you will get this guide. And that I'll be giving it to you. I've been signed out. I don't know why though. Yeah, NP level knowledge would be good because they talk about some of these things at that level. So if things are familiar, right, you will have a little bit of, you'll find it a little bit easy to grasp them, and that interest will be there. I'm sure that, yeah, today I have close to 210 of you. I hope that all of you stick with me on this journey. It's not going to be easy. There are some things which will be difficult. But stick along, and wherever it's required, I'll keep adding them here, like, okay, explore this, do that, add, try this hands-on, and so that you'll be able to relate this reference guide and the things that we discuss in the class, and you should gain significantly from this boot camp. That's our ultimate. Okay, so we'll set a time to look at the chat. Whenever we want to take a break, we'll look at the chat. Otherwise, at the end, if someone has really a burning question which is required for understanding, for example, I'm talking about Terraform, and unless you get that clarified, you'll not be able to understand anything further. Probably, is there an option to raise a hand or something? Probably that also comes into the chat. And my request is questions, right? These kind of generic questions. Is this required? Is that required? Please keep it to the end. We'll have a detailed Q&A session at the end. Okay, so that's a little bit about cloud and what is Terraform and what Terraform can do in that context, in the cloud context, right? If cloud is like
is like dynamically provisioning infrastructure. Then Terraform is the tool which can automate this process. Right? You can without the Terraform also you can do this, but it will be a manual process. So creating large number of resources in a repetitive manner again and again and again is going to be tedious, very tedious. So that's where these tools will come to your rescue. So officially, what is Terraform? Terraform is termed as infrastructure as a code. If you notice this term carefully, right? Infrastructure as code, which means you're defining your infrastructure using a code. Right? So you would have heard these terms a lot since the cloud started picking up, right? SaaS, PaaS, right? Software as a service, platform as a service, application as a service, all these things. So the next level is when we came down to infrastructure level. So either we can, the cloud guys precisely do that, right? You have something called as compute service. Using the compute service, you will be creating your compute machines. Compute service is nothing but the service which you use to create your VMs. Right? So you already have infrastructure as a service. Now, the tool specifically, you already have infrastructure as a service provided by AWS, Azure, and so on. What this tool is doing is it is automating this process of provisioning that infrastructure. So you write code to automate this process, to automatically generate whatever infrastructure that you're looking for. So that's why we call this as infrastructure as code. And what you can do with it, you can build infrastructure, you can build resources, you can modify them, you can destroy them. Right? Now, what do we mean by code? We define the resources. What are resources? Like you're creating VM, right? If you have ever created a VM on the cloud platforms, what all you will be needing? First, you need the VM itself. Then that VM needs an IP address, public IP address. Then you need a virtual network. Now, if you of which this VM is going to be part of it. And within that virtual network, if you want to have segmentation, you will have subnets. So to create one VM, you will have to create so many other dependencies. All these are going to be your resources, right? So those resources, we'll be defining them in human readable configuration file. That is the code that we'll be writing. Resources are defined in human readable configuration files. Now, once you have that human configuration file, you can version it. Let's say you're working on project 1, where your client requires Ubuntu 20.04 server. Right? So you create a Terraform config file for that, use for creating that infrastructure. Then you move on to another project. Here, the client doesn't want 20.04. He wants you to use 22.04. Right? Now you are creating similar kind of configuration. So you normally when we want to create similar kind of things, right? We use the concept of versioning. Right? That's what the programmers also do. Programmers keep modifying. They write one version, they write one code, they modify the code tomorrow, day after tomorrow they'll add more code. So there's a concept called as versioning, which you'll be seeing going forward. So now the code, the Terraform code, configuration files that you're writing can also be versioned. So the file which I've written where Ubuntu 20.04 was being created is version 1. The one where you have modified that 20.04 to 22.04 is version 2. Why do you do that? You don't want to throw away the previous code. right? Suppose there's some other client who comes tomorrow and says, I want to work with Ubuntu 20.04. You create them for me. Again, you'll have to modify. If you had thrown it away, again, you'll have to recreate it or modify the existing one, right? Now you have it, you simply find out which version is that and then use that version. So that's why versioning is important. So that is another advantage. First advantage is the code is going to be human readable and so that the person who is writing can easily understand. Second advantage is now that it is available in the form of a file, it can be treated like any other code. It can be versioned, it can be source controlled, it can be backed up. And third advantage is it also acts as your inventory, your documentation. Right? Normally in the networking world or the sysadmins, there's a big challenge, right? Maintaining the repository of all the servers, all the switches, routers, network resources, network devices, or the network resources that they are creating, modifying, that they are using with. Maintaining a repository of them is a real nightmare, right? You maintain Excel sheets, the Excel sheet versions keep changing. You don't know which one is the latest version. You'll have to resort to some online tools like Netbox or IPAM solutions for that instance. And so all these challenges are there. So this Terraform or infrastructure as a code approach solves that problem to a certain extent. Right? Now you have one version of your Terraform config file created, which talks about what are the resources that it has created. It talks about, yes, I've created so-and-so Ubuntu 20.04 VMs, about 100. And then these many VNets I've created. Now within VNet, within each VNet, I've created these many subnets. Look at tomorrow or that at any point of time I look at this Terraform file, everything is there, and you don't need a separate documentation. Your entire project inventory is there in that file. So indirectly, that profile is also going to help you as a project repository. And what can it do? It can manage low-level resources like your compute, storage, networking, as well as high-level resources like DNS entries, SaaS features, and so on. So if you see AWS, right? In AWS, I can create, I just want to use virtual machines. I can create virtual machines. Let's say I want virtual machine with Python, right? I'll find that template and create it. I want database. I'll directly search for a database and create it, and then I can start using that database, right? Which means I don't have to take a bare bones VM and install things on top of it. Right? That is one way. You can still do that if you want to control. But these guys have pre-created images for almost anything that you need. You need database, you need DNS servers. Everything has pretty much been made available to you as images so that you can directly create their instances and start using them. So those are like your low level and high level. Low level is you create bare VMs and install everything on top of it. Otherwise, you directly have like your databases, your applications, your web servers already available as images. Directly you can provision those resources. Okay, so that's about what is Terraform. Let's take a minute to look at if any burning questions are there. What scripting language does it use? It uses a custom language called as HCL, HashiCorp config language. It also supports JSON. Download links, I mean, I don't mind sharing, but I don't want to drive your attention away from what is being discussed, right? Anyway, there's nothing that you will immediately do by setting it up. Setting it up is going to take some time. So just be patient. I'll give the document at the end of the session, then you can download and install. How do you compare Terraform and Ansible? That's a good question. Ansible is a configuration management tool, right? Ansible comes after you procure the server, right? Terraform is one step before that. Terraform is infrastructure as a code tool. You procure infrastructure machines, VMs using Terraform, then you can configure them using Ansible. So that way they complement each other. Okay. Infrastructure as a code is, as you're going to see very soon, we will write a file where we declare what you need. What is the infrastructure that you need, rather than giving the details about how to go about building that tool. So we call this as a declarative style of programming, right? In programming, we give detailed instructions. That's called as imperative programming. But the other case, like the tools like Ansible, Terraform, they all use declarative, which means they declare, right? What Ansible does, it has a playbook. It says, okay, these are the hosts. You need to go to the host. You need to use this module. You need to install this web server. Right? It just tells what it needs, what needs to be done. Same way, the Terraform is going to let you declare what you need. You say what to use, which provider to use, what do you need, what is the resource that you are creating. So that you specify as your code. Terraform takes this code in the background. It understands how to interpret this code and how to carry it out, how to execute what you have mentioned there. And the result is you have your infrastructure up and running. And for example, I write one Terraform file where I specify I'll be using Azure as my provider. And I want to create an Azure VM with this name, with this image, with so-and-so amount of RAM. I just declare this is what I need. And I give that file to Terraform. Terraform figures out how to connect to Azure cloud, where to get that Azure resource manager from, and how to create an Azure VM, how to assign IP address to that, and finally give it to me, give that details to me, so that I can connect it to via SSH or RDP or any of these mechanisms. So in that sense, we are writing code to procure infrastructure. So that's why we call this, and your tools, this IAC tools, infrastructure as a code tool, uses the code that you have written to put your infrastructure in place. So in that sense, we call these tools as infrastructure as code tools. Okay, how do we install? Installation is pretty much simple. If you are on Windows, you can just it is available as a executable. You can just download it, put it in path, and you have it up and running. Right, Terraform is by a company called as HashiCorp. You search for Terraform download. Right, you come to this page. You have your operating system of choice. If it's Windows, you just download it. This is about the zip file. It's downloaded as a zip file, which is about 20 MB in size. When you unzip it, it becomes about 60 MB. Place it in some location. The zip file just contains an executable. It is available as an executable. And this is where my executable is located, terraform.exe. It's about this in size. But now this is available as executable, but there's no UI. There's only a command line tool, right? So I'll have to open my command prompt.terminal, and I should be able to use this with this form. Now, to be able to use it from anywhere, this exe needs to be in path, right? So you'll have to edit environment variables. And then search for environment variable path. Add it there. Add the folder where that exe is located as one of the variable. Click new and paste that path here and then say OK. Once it is in path, then from anywhere on your command prompt, you can just give that command terraform. And the basic command that we give with any tool is version. Check its version using -version. So this is how you can install it. And in Linux also, we can do pretty much the same. We can download the executable, unzip it, then into some folder, take that folder, add it to your path. You will have it available from anywhere. Or it is also available as a using your repository managers like your apt. So you just need to add this repository from where this can be downloaded to your list of repositories, download some keys, and then using your sudo apt update and sudo apt install Terraform, you can install. All the instructions are given here in this link. Yes, it is already installed. And it's a little older version, but doesn't matter. Right, if you're here, then Terraform, it's already installed. Right, it's a little older version, doesn't matter, as I said. This is good enough for our work. Okay, so that's about installation. If you want to install on your own this thing, you can go to this link. Now, how does Terraform work? How does Terraform work is you would have got a feel of it by now, right? Using Terraform, I can create AWS resources, I can create Google resources, I can create Docker images, I can create Cisco ACIE resources, right? You might think, okay, Terraform is some sort of a super tool, Superman, right? It is not. It is just it's just a enabler, right? It's a kind of framework. But to actually go and do the task on AWS, Azure, Google, or Cisco or Docker, you need to have those pieces, components, which know how to interact with AWS, how to create a VM remotely, right? So they have to, the underlying platforms should have exposed a way which can be, using which these things can be created programmatically, remotely, without going to their respective UIs. Those things are called as providers, right? The tools which will help you to interact with the underlying platforms and create this stuff are called as providers. So Terraform has huge number of providers. That's the magic of Terraform. How Terraform does all this magic? Using its ecosystem of providers. Now, what are providers? Let's say you want to create AWS VM. Right? Terraform doesn't know how to connect to AWS, how to create a VM remotely. So AWS guys have created something called as a provider, And they said, okay, Terraform can take this provider and do the stuff, whatever needs to be done. So like this, every vendor started creating their own providers. Sometimes it is vendors themselves, or sometimes some open source guys. Right? So using these providers, Terraform is able to connect to the remote systems and perform actions on them. What is the action? Creating resources. Creating, managing, destroying, whatever actions that need to be done. Okay, providers enable Terraform to work with virtually any platform or service with an accessible API. Let's say I'm like Red Hat. So I recently came up with my own cloud platform, right? I want to make things simpler by letting anyone create my resources like VMs or anything for that matter using Terraform. So what I have to do? I have to talk to Terraform guys, like how to write providers for your platform. They'll give me some instructions. This is how you need to write. So I'll write that code and make that available as a provider. Where will I put this provider? Terraform has given us a place called as Terraform registry. It's like a public forum, a public website, public repository where these providers can be uploaded. Now, Terraform registry is somewhat similar to your apt. If you have worked only with Linux, you have your RHEL repository from where the packages are downloaded using the package managers. Right? If you have worked with Python, you have a Python package index from where you can download and install the stuff simply by saying pip install something. If you have worked with Ansible, Ansible has a concept of Galaxy from where you can download the roles, collections, etc. using the command line. Right? If you have worked with Docker, you have something called as Docker Hub from where you can download the images. Same way, Terraform has this repository called as Terraform registry where different people upload their providers. Now, all these platforms, right, Ansible, Galaxy, Docker Hub, Terraform registry, they divided their space into partners, the others, right? Partners means like AWS guy is creating his provider. Azure guy is creating his provider. Right? They are like well-known guys. So they partnered with Terraform. So Terraform separately provides, has given a separate space for uploading these providers. Like I can write my own provider, upload to Terraform registry. Right? Like this, there'll be thousands of people like me who would have created their own providers. But obviously, when we try to look for these providers, the partners, the guys, the companies who have been validated by Terraform, they show up on top. Okay? So because they are like stable, they are like recommended, they are like trustworthy. Okay. This is how Terraform registry looks. Click on browse providers. You have these guys are like the big players: AWS, Azure, Kubernetes, Alibaba Cloud, etc. So these are all like small players. These are partners. So they have classified them as partners. 65 pages, and then still like there are about 65 pages. So you see, so many people have written their own providers. So pretty much anyone, yeah, these are official, partner, and community. Official is those big guys, right? AWS, all those guys, if they create the providers, they're like published officially. Partners are some other companies with whom they have tie-up. Community is anyone else. This is pretty much same concept in case of Docker also. Docker also has a concept of hub, Docker hub. There we call them as namespaces. They call them as root namespace, user namespace, and custom namespace, something like that. Anyway, that we'll be revisiting. So this is like your collection of Terraform providers. These providers are like your workhorses who actually do the task. So Terraform is nothing without these providers. These providers are nothing without the Terraform framework. And they're like kind of married to each other. Each one needs the other. Terraform needs the providers, and providers need Terraform. So Terraform is like a framework. Providers can sit on top of this framework, carrying out their tasks. Okay. If I want Azure resources to be created, I come here and then click on this, use that provider. It gives me some code how to use your Azure provider. Where is your Azure provider located and how to use it within your code. Okay, we'll come to this in a minute. Where did I add a path? In system environment variables. Terraform registry is not like Ansible modules. Terraform providers are like Ansible modules. Terraform registry is like our Ansible Galaxy. Okay. How does Terraform work? With the help of providers. Providers enable Terraform to work virtually with any platform. Now you see there are no restrictions. There is a new platform. The new platform just needs to get in touch with Terraform. How to write the providers? Write the providers. Terraform is able to work with the new platform now. New platform or a service with an accessible API. So all this happen through something called as APIs, application programming interfaces, right? To put in simple terms, whenever we open any application, for example, I open this page, right? I'm interacting with this. I'm clicking here. Where was the other one? Yeah. I open this. I'm clicking here to see this code. So I'm interacting with this application using this UI, GUI, graphical user interface. Same thing, let's say programmatically, I want to get the list of all the providers. From that, I want to pick up Azure RM. From that, I want to pick up this text, right? So someone can expose all this functionality in the background without the UI, so that I can write code to perform the same thing. That, in short, is API, Application Programming Interface. Exposing the functionality as if not a human being, but some other application would use it, right? Human to software interaction happens via GUI, Graphical User Interface. Application to software to software interaction happens via API, Application Programming Interface. So nowadays, everyone is exposing their functionalities via APIs. You don't have to necessarily go to UI to be able to do that stuff. For everything that you can think of, nowadays there are APIs, and you can do the stuff using APIs. So I'll give you one best website. There is a website called as Netbox. Demo.netbox.dev. This link I'll give you in the chat. This is just for your information sake. If you want to explore what are APIs and what is their power, this is not really this thing. Right? So there's a site, right? As I said, this is a site This is an open source platform which will help you to manage the inventory of your like data center. You can manage your sites, tenants, contacts, providers, circuits, networks, clusters, virtual machines. You name it, you can add it here. And default username password is admin. Oh, okay, they disabled it. Hopefully it still works. Yeah, it does. Like you can create you can create sites, regions, site groups under organization. You can create your devices, right? So there's like a software which will help you to manage your right? Now why I'm showing this is all UI, right? If I want to create a new device, I click here. I'll have to enter these details manually and then do this. But if I want to do this programmatically through automation, right? I click here. You see, whatever we saw there, the category is devices, connections, site PAM. Right? All that you see, they have been classified into these, like something to do with the devices. For example, they are under DCIM. Let's say sites. So you see, through code, I'm getting list of sites. Now this is like read. I have read. Same way, I can also create. There is something called as get, post, put, patch, delete. Get is like for reading. I want to read circuits information. I call this API. I want to create a new something related to circuit. I use this. I want to modify it. I use put and patch. I want to delete something. I use this. So whatever you can do on UI, you can do pretty much everything through APIs. So this is a best example where you have almost everything in the UI is exposed as REST APIs. So if you want to learn REST APIs and want a good site for practice, this is the place you can come. Yeah. API is like application programming interface. It's like a way two programs can talk to each other and use each other. Right now, I have a website into which I can log in. For example, Amazon. Right, I log into Amazon using my username password. I go to product page where I search for the product which I'm interested in. Then I go through the details of the product. I say, okay, I like it, add it to the cart, click on the button, add it to the cart, then click on the cart, go to the cart, and then be able to do something. And now that is if I'm doing manually. Yeah, as a human being, I'm interacting with Amazon application using something called as GUI, graphical user interface. But suppose I want to automate things, right? In an automated way, I want to log in. I want to do a product search. I want to pick a product which suits my needs and add it to the cart. Right? So Amazon guys should give me these kind of links, which I can put in my code to, okay, click this link, pass username, password, you are logged in. Click this link, enter the product name, enter the search, click this link by, call this link by passing the product that you want to search for, you get a list of products. Right? So that way I can establish connectivity between two programs. One program can call the other program to get work done. So this interface between the two programs is called as API, Application Programming Interface. As I said, the best example is this. Now these links, right? I can take this link, put in my Python code to get the details of this site, or I can invoke it from tool called as Postman, which will help you to work with APIs. Or I can write an Ansible playbook to do something with this thing. So that way I've achieved automation. Right? Normally to get, let's say, to modify this site, I'll have to go to UI, go to the site with this name, Butler Communication, and do something. Let's say change its status from active to inactive or something. Now, programmatically, I can do this because that is exposed as an API, like this kind of URL. So, same way, Terraform and those providers Terraform providers interact with the underlying platform via these APIs. Right now, you see, Terraform has an Azure provider. It has to remotely connect. It has to remotely create a VM, remotely create a network, VNet, subnet. So it has to go through. It goes through API layer. Yes, it primarily works on HTTP. Netbox tool is some guy developed an open source tool for. Initially, it started as IPAM tool, IP address management tool, and slowly it went on adding many other features. Now you can use it for managing your entire data center, even to the extent of you can add racks, cables, even the cables that you are using to connect your devices within your data center. Even those can be data about those can be entered into Netbox tool, so that your complete inventory is maintained. APIs, if it is, you cannot build someone else's APIs on top of someone else's software. If you are writing a software, you will expose your software's functionality via API. So whoever, for example, Cisco has so many products. So Cisco has to write those APIs and expose its functionality so that we can use it for automation. Yeah, you can see that now. Okay, so that's how Terraform works. It makes use of those providers. Now, what is the workflow, right? You decide what you want to create. You figure out which provider to use. You write your script in certain syntax, as we are going to see, using a language called as HCL, HashiCorp config language, which defines the infrastructure in a declarative fashion. Then we execute the plan. We check the plan, right? Because we are dealing with infrastructure. Simply by writing a file, and then let's say if it is creating, also it is going to costly. It's going to cost you money. But worst thing is destroying. If you just write some instructions and destroy something which is being used, right? We are in a soup. So since we are doing something risky, something that cannot be undone so easily, it's always good to do 2-3 dry runs and check and ensure that yes, we are doing what we really intend to do. So they have a concept called as plan. You can create a plan. I mean, Terraform, based on what the config file that you write, you can use a command called as plan to generate a plan, which shows you what exactly it is going to do. Then we take the plan and then we say, yes, I'm satisfied. Apply this plan now. And then it goes and creates the resources. Okay, so within the file, we'll have something called as resource blocks, because resources are the most basic elements that we'll be creating. Anything that you'll be creating will become a resource. Even a VM that you're creating is a resource. IP address that you're creating is a resource. VNet, subnet, all these things are resources. The Docker images that you create is a resource. Right? Resource is the most important and most basic element in Terraform language. Each resource block describes one or more infrastructure objects such as virtual networks, compute engines, higher level Docker images, containers, etc. What's the syntax? We say resource block starts with something called as a resource, right? Resource and the type of the resource. What is the type of the resource that you are creating, and the name that you want to give to that resource within this file. Okay. If there is a the example that we'll be taking first is Docker, and that's because not everyone may have access to ACI, the other example that I'll be showing, right? So since we may not have access to ACI, so that is a Cisco's product application centric infrastructure, I've taken an example with Docker, which you have on your CWS also. If you're new to Docker, I would request you to brush up your Docker basics as well. But at a very high level, it is something like your VM virtualization. It's not exactly that, but roughly you can compare it to that. So Docker has a concept of images and containers. So Docker images are like your virtual machine templates. Docker containers are like your running instances of virtual machines. Okay, so further probably you can check. And anyway, at the end, in one of the tasks, we have Docker, so that time we'll be getting into the Docker basics as well. So for the time being, that's what you just need to understand. Here we are creating a Docker image and using that image to create a container. Okay, so those are the resources, and there is some syntax that you need to follow for resources. And little bit about providers, right? You can read up what is provider. Each resource type is implemented by a provider, which is pretty much like a plugin. Providers are distributed separately apart from Terraform itself, right? Obviously, because there are thousands of providers. Not all the thousands of providers can readily come with Terraform, right? Then instead of 60 MB, it will become 600 MB or 6 GB. So to prevent that, the providers have been separated from Terraform itself. By convention, the resource type names start with provider's preferred local name. Every Terraform provider has its own documentation. Okay. Let's jump into an example. Okay. So we can start writing the config file. We call these files as config files because we are specifying the configuration of the resource that we are trying to create. It starts with first you need to tell which is the provider which is required to be downloaded for you to carry out this task, right? In this case, Docker, it is Docker. So I'll say Terraform, I need Docker as my required providers. Then I specify the name Docker. Now I need to tell from where to get it, source, and which version of it to get. The source is like a partial link. This partial link is with reference to Terraform registry. On Terraform registry under providers, this path exists. Okay. So you see this language, this is not JSON. This is not any other language. This is known as HCL, HashiCorp config language. They try to make it very simple, right? For example, we are describing some complex object called as required providers, inside which we will say what is your required provider. That will have a couple of values that needs to be specified. So all this is wrapped inside this curly braces, and we give this directive. We are telling Terraform something, sending some information to Terraform. So whenever we have this kind of complex thing, there's a curly brace which starts and ends. Between curly braces, we specify this. Now, for example, you see this source. Source is just a string, right? Just a collection of characters. So there's no curly brace that is starting. Directly we say source is equal to this. Same way version is equal to greater than or equal to 3.02. So these are like simple objects. These are like complex objects. Okay. So that is somewhat, this is the syntax which you have to get used to, right? Initially, it's going to be a little strange, little difficult. You will wonder why there is a equals sign here, why it is not here, right? These kind of things. That's because Terraform is a keyword, right? I'm defining a Terraform block where I'll be specifying required providers. Inside this Terraform block, I'll have required providers block. These are like blocks, predefined blocks. Inside required providers, I'm giving this a name. This is not required provider with this name. So that's why I choose this name. And then I have to tell equal to Docker is equal to this. This guy, to this guy, I'm giving a name called as Docker. So wherever I'm referencing, I'm going to use this name Docker. So this way, why there is no equality symbol here, why it is here, you will get used to, right? Initially, you will find it challenged. Then simply you can refer to the documentation to see like what is the correct way to access these things till you get comfortable with this kind of syntax. Okay, we specified what is the provider which I need for what is my first. You have to start with objective. What is my objective? I need to create one Docker image or like your VM template. From that, using the Docker image, I want to create one running instance, running container, running Docker container. Okay. Now these are to do with Docker. So obviously the required provider in this case is Docker. So I go to Terraform registry and search for Docker. Where is this Docker guy? Page not found. Yeah. Right. So in this, there are so many, right? So most of the times this happens. So now you will be confused whether to take this or this. So you click on this and see its rating. There is no official provider for this, but you check most of the examples like AWS Docker example, Azure Docker example. They have taken this guy. So it looks like this is the official Docker image, right? So as I said, click on this. You will get your how to write that block. Terraform, required providers, Docker, source is this, version is this, and the provider block. And you can directly copy this and paste it at the top of your file. So Terraform, required providers, this. Then you are saying, okay, I've defined my provider here. I'll be using it. So I'm saying provider, which is the provider that you're going to use? Docker. This curly braces need to be put here just in case if you have any config settings to be done, like any additional information to be passed to start using this Docker container, those will come. In this case, there is nothing. Then once that is done, you are saying, yes, now I'm ready to start creating my resource. What is the first resource that you're trying to create? Docker image, right? So typically the name of the resource, the type of the resource is going to be name of the provider underscore the type of the image, right? What you're trying to create, image. Who is the provider? Docker. So your resource type is going to be Docker underscore image. Which image you're trying to create? Docker image. That is greater than or equal to symbol. Yes, a specific person has created this provider, but that has become like official because most of the Azure guys, AWS guys, while giving Docker, Terraform Docker examples, they use this provider. Okay. So what I am saying is, I am creating a Docker image called like, let's say I want to create a web server. Right? It's like saying, yeah, I want to create a VM and install some web server inside that. Now, instead of creating a VM, instead of installing operating system and then installing web server on top of that, you have a predefined Docker image for that. You just take that Docker image, you have everything in it, right? So that Docker image can either be Apache 2 in case of Ubuntu, or there is another option called Nginx. Nginx is like a web server and proxy server. Typically, we use this if you quickly want to set up some web server. So it's a small, lightweight web server, right? So I want to create one image, which means a template. And then from this template, I want to create a Docker container, which is like a running instance. So I can give some name to it, my web server. It will be up and running. Then, since there's a web server, I'll run it on port 80. Right now, inside that VM or inside the container, it will be running on port 80. But from my host machine, I want to access it, let's say port 8000. So I'll have to establish this mapping. So that is, these are nothing to do with Terraform. These are like the application specific configuration settings. Since we are creating Docker container, this is what we need to know. Let's say I'm creating something to do with ACI. So I need to know, okay, ACI, application centric infrastructure, as a concept of tenants. Then everything starts from a tenant. Inside tenant, you have VRFs, bridge domains, and so on and so forth. So these are nothing to do with Terraform itself. These are the nitty-gritties of the resource that we are trying to create using Terraform. So you need to know a little bit of both. You need to know how to work with Terraform. You need to know a little bit about what you are trying to create. Okay. So here I'm saying, yeah, I want to create a Docker image. I want to give a name, Nginx image to it. Now, which image should be used? In Docker, we have a base image that is called as Nginx, a latest version of it. It has different versions. So I want to use the latest version. Now there's additional setting that is given to us saying, after its work is done, do you still want to keep that container, or should I delete it? So we normally say, don't keep it. Once its work is done, delete it. So these values that we are giving inside these resources are specific to this. So every resource that you're creating will need different details. For example, in Docker, to create a Nginx image, we just need one command, Docker pull Nginx, right? So we are saying create Docker image called this, which image to create, Nginx. Then you might ask, what is this name? Right? What is this name or what is this name? This name here is kind of local name. Within the script, you want to give a name to this Docker image. That is this name. Why is that required? Because there might be some other resources which are dependent on this resource. So those dependent resources will refer to this guy as using that name. Okay. For example, there's like your Docker image or VM template. Based on this, you want to create Docker container, right? So in Docker container, you need to specify this container should be based on which image. So the reference will be Docker image dot Nginx image, Docker image dot Nginx image dot ID or image ID, any unique way you can identify. Once this image is created, it gets an image ID, like a ID. So for creating container, I'll be needing the image details which has been created, because container will be based on the image. So then the way you refer to it is container resource type dot resource local name dot unique identifier. And then what you want to call your Docker container as some XYZ, ABC, XYZ. And then this is the port stuff. Map host port 8002, internal container port 80. Okay. So these writing resources will differ from the application to application. This is the way a simple Docker container can be created. Docker is a kind of container. Container concept is right, but which holds the value of variable is not. It's a container is like you want to pack everything like a mini OS. Let's say you want to go on a trip, right? In let's say European or Western countries, they go on a camping trip. So they pack everything that they have into their caravan kind of thing, which gets attached to their car, and then they go with it. And then they just put that container there, and they have everything which is sufficient inside the container itself. Same way, let's say I want to work with Python, right? I don't want to install Python on that. I'll say I need a Python container. So what is required for Python to run? Python requires a base OS and Python installed along with whatever is required for Python to work. So everything is packed into that Python container and it is available on Docker Hub. All I need to do is borrow it. Same way I want to work with, let's say, a database. What all are required for you to install a database? Many things. First, you need a base OS. On top of it, you need to install a database. You need to do its configuration settings. Instead, you get a Docker image with everything preset. And so that is Docker for you. How to configure the code for resources, like I have taken code from registry, documentation. Now, there's a detailed documentation for every resource. You can go and check, right? For example, Yeah, someone has already answered it. Here, image ID is like a property which is available on that image once it's created by Terraform. You can also use just ID. Okay, that also works. So the image which gets created by Terraform gets its unique ID, which is stored in a built-in. So that we can think of it as a built-in variable. So the image gets a built-in variable called as image ID, which is what we are using for referencing it uniquely. Okay. So assuming that you have managed to write this based on documentation. Now, first, right, as I said, Terraform is just about 60 MB. It doesn't come with any of the frills attached. So first, you're saying, yeah, you're going to use Docker provider. First, you need to download the Docker provider. You need to tell Terraform to get that Docker provider. So you do that, saying Terraform init, initialize my Terraform with whatever, by procuring whatever provider is being used, right? So you simply say Terraform init. It figures out, it looks into the current folder for a file. By the way, we'll be putting this code into a file called as main.tf. The file name extension is going to be .tf. Right? Typically, we call it main, so that we don't. There's a default name Terraform looks for. So unless I have multiple TF files lying around, config files. So I'll name my file as main.tf. So once I name it as main.tf, I'll simply say Terraform init. It looks for main.tf. It goes to the top, sees the provider section, sees that it is this. Then it connects to Terraform registry, downloads this, puts it in the local folder. And that's what Terraform does. And then we say Terraform plan. Terraform plan will go through your resource blocks. It says, oh, okay, I need to create an image. I need to create a container based on that image. So it says there are 2 resources to be created, 0 to be modified, 0 to be deleted, and so on. So it generates a plan. Then if I'm satisfied with the plan, I want to go ahead, I'll say Terraform apply. It again shows you the plan, asking you to confirm. You say yes, it goes ahead and creates these resources. Now let's say you're done with your work. Now you don't need those Docker container, Docker image anymore, right? You simply say Terraform destroy. So Terraform remembers what are the resources which it has created. It remembers it created an image, it created a container, and when you ask it to destroy, it destroys them. It just deletes them. Yes, it is applicable for all these cloud platforms. Where to get this documentation? The general documentation you will get from internet. This document I'll send it. I'll share it after this. I'll be sharing it in, wherever you got the link from the same groups, you'll be getting the link, the meeting link from the same group. On the same group, you'll be getting this link as well. Yes, we'll be doing the hands-on now. So let's quickly jump to the CWS. Yeah, for your hands-on, I have put these things here. What is the hands-on that you need to do? Hands-on 1, you do this. Hands-on 2, you need this. Okay. Where am I? Okay, so I created a work folder. I went to whatever folder path I want. Then from here, let's say I have to start writing code. Now, writing in this Linux editors is little painful. Moreover, so we want to make use of this IDE, Visual Studio Code. So from here, there's a shortcut way to directly open it in this folder. Code is the shortcut for Visual Studio Code. You say open code in current folder, code dot. It opens in this folder. Now you say new file, main.tf. Okay, so the moment I said tf, it identified it's a Terraform file and replaced with its icon. Right? Now either I can copy that code from there or I can do this. Now, how it is able to prompt is the first time it sees Visual Studio Code sees that you have created a TF file, right? Here it gives one small tip. Looks like you're trying to work with Terraform. I have a nice plugin for you in my marketplace, right? This Visual Studio Code also has a good marketplace with a large number of extensions, which will simplify the process of your process of writing code. Right? It prompts you saying, yeah, in my marketplace, there's a plugin for Terraform. Would you like to search for it? You say, okay. It directly takes you to something like a Terraform plugin. This one. This guy by HashiCorp itself. So initially this will be like install. You say install it. It gets installed. From then your, you see your, this is called as IntelliSense. We call this as IntelliSense. Where you type part of the command, it automatically prompts the rest of the stuff. So here I know that it starts with Terraform. So it prompted me with Terraform. And it identified this as block. So how this is all coming is, it is coming from this plugin. I hit tab, rest of it is completed. Then I'll say required providers. If it is not automatically prompting, you hit Control spacebar, you get the prompt. Right? Required providers, hit tab, you get it. Now you say my required provider is Docker. Source is something, then version is something. Now that's something you can get from there. Okay. Hope I'll be able to copy it from here to there. No, I can't. Okay, this indentation doesn't really matter in this case. In some other cases like your Ansible, Python, it matters. And you also have some plugins called as Prettier, which will nicely take care of this indentation the moment you save these files. And you say your provider is Docker. By the way, we are trying to create a Docker container here, which means the Docker should be installed and it should be running in the background. So there are no specific files which are required. Now you have to create a resource. So start with the resource block. The type of the resource will come here. It is Docker, which is this provider name, underscore image, the type, and some local name, right? My image. Right. Just like giving the command right now. Let me check if I already have it. Docker images. Docker requires some permissions to be given. I should add it to the. Right, I already have it, so let me get rid of it. As of now, I have Python images. So, and this is the way I can check if containers are there. There are no running containers. So I'll be creating an image. This name will be used within this. I'll be creating an image called as Nginx. Now, based on this, I'll create a container as well. Right, resource Docker underscore container. Now, Docker container needs parameter to be passed. First parameter is image, based on which image you want me to create this container. It should be this dot this. It's like complete path, complete name needs to be given. Dot ID, ID or image ID, both should work, but let's try with ID. And then you want to give some name to your container. My web server. Okay. Then port mapping. Okay. So my file is ready. So I'll go and say Terraform init. Right. Let me show you that ls-a. As of now, I only have main.tf file, right? Nothing else. Now, the moment I say init, some hidden folders are going to be created. So it's initializing, it's downloading that plugin, bringing it and placing it in your, so it has done that. Now you do ls-a, you have this .terraform and some other file, right? You can go inside this .terraform. You will realize that. Let me quickly take you in this Explorer. .terraform. Registry. Yeah, this is a complete path. .terraform, providers, registry.terraform.io, close Docker 3.2. Finally, this is your, where is it? Right, so this is your provider. This is a binary file. This is what has been downloaded, and yeah, this is the one. This is your binary file which is downloaded, and this is going to do your task of creating image and creating a container. This is just for your information purpose. Okay. Docker plan. Sorry, not Docker. Terraform plan. So it has detected that, yes, this is what I need to do. Right? I need to create one container. You see, we gave just one or two values, but these are the values it's going to create with. So most of them will be like default, and it needs to create image. This is image. This was container, so it's going to create both of them. So it said 2 to add, 0 to change, 0 to destroy. So this is how it shows how many resources it's going to create, how many it's going to change, how many it's going to destroy. Then once you ensure that, yes, this is what I intend, you say Terraform apply. It's going to show the same thing again and ask you to confirm. You say yes. Unable to inspect, no such image. Here's some spelling mistake. No, Nginx : latest. Okay, I think it should be image underscore ID. Okay, this is interesting situation. Terraform state list. Image has been created, but not container. Terraform destroy. Okay, it is created. Docker images, Docker PS. So it is running and it is accessible on port 9000. You can say localhost port 9000, we get the page. Right, say Terraform destroyed. Those are gone. You will no longer be able to access. From where it's going to download the image? From Docker Hub. Right. Now, as I said, like Terraform is giving a command like resource, this, that. Ultimately, by Docker provider, it's going to be translated into Docker commands. Right. What is the Docker command to pull an image? Docker pull so and so. What's the Docker command to create a container? Docker run from this image, export port, expose ports, and so on. So those Terraform commands will in turn be translated into Docker commands by the provider. What kind of image? Nginx is like a simple web server. Now it's doing on local. Right? What do you want to do on a? How do you want to do on a different this thing? Pre-recorded videos are not there. Yeah, you can take from ChatGPT. We'll do it in next class for Cisco SCA. We are running out of time. So we can keep the next 3-4 minutes for any general questions. So I specified 9000. You can cross-check. 80 is internal, which means inside the container, your Nginx will be running on port 80, which is mapped to 9000 on the host.